As we work with the laws of exponents, this should be a review from what you've worked with in previous years to include as far back as 8th grade, where we really start to discover the exponent and the power. And the power is going to look something like this right here. This is a power where we have a base of a and a exponent of 4. And the base is the number that is being multiplied times itself 4 times. So if we expanded that out, that would look like a to the first times a to the first times a to the first times a to the first, because we are going to be multiplying a 4 times. So that is the general expanded expression of a power. And now what we're going to do is to try to make things a little bit easier on us. We're going to go ahead and figure out how to manipulate these and use the laws, which will speed things up. So as we looking at this example right here, we have a to the first. This could be rewritten as a to the first plus a to the first, or a 1 with the exponent of 1 plus 1 plus 1 plus 1, which means we have a to the 4th. As we talk about the power of products, well, the quotient rule, if we look at an example of something that we may have seen in algebra, where we have x to the 4th over x to the 4th y to the 2nd over x squared y. And we would simplify that, and we might simplify it by writing it out, that I would have x times x times x times x times y and y, all of that over x times x, y. And we may have been taught to cancel everything out, because y divided by y is going to give me 1, and x divided by x is going to give me 1, and x divided by x is going to give me 1. And then when I simplify it, what do I have left? Well, I have x squared y over 1, or just x squared y. Well, what happened is, when in the quotient rule there, we actually were subtracting. This was x to the first minus x to the first, which gave me x to the 0 power, which is 1. So looking at when we have like bases, I'm going to spread this first example out a little bit. I have 12 over 2 times x to the 9th over x to the 3rd, which is the same thing as, we can rewrite that as 6 times x to the 9 minus 3, which is going to be equal to 6x to the 6th, okay? Because when dividing, I subtract my exponents. Now, this next example, again, we're going to do the same thing. I'm going to go ahead and write it out, and I'm going to line up the things that I can, my like basis, so my real numbers are going to be like, and then I'm going to have a to the 6th over a to the 2nd, and I'm going to have b over 1, and I'm going to have c to the 4th over c to the 4th. And I hope here, if we do some simplifying, we can see that this is going to simplify down to 3 over 7. This is going to simplify down to 1. So I'm going to have 3 over 7 times a to the 6th minus 2 times b, and that is going to be 3 over 7 a to the 4th b. There you go. And that is going to be my simplified expression. Simplified expression. So that is using the quotient rule. We're using subtraction. A power raised to a power now. This was in that first example that we were doing when we were doing multiplication and adding the products, but I expanded it out instead of just doing the product rule. So here, in this first example, I have 8 to the 3rd raised to the 21st, and then equals 8 to some value. Well, if I go ahead and looking at my rule, a power raised to a power is going to be multiplication. So that here I have a power raised to a power, so I know that that's going to be multiplication. So that is the same thing as 8 to the 3rd times 7 equals 8 to the n, or 8 to the 21st equals 8 to the n. And if I have like bases, then I can make my exponents equal to each other. So technically n is going to be equal to 21. So there you go, n is 21. And if you rewrote that, that would tell me that, hey, guess what? 8 to the 21st is equal to 8 to the 21st. Okay, just by substituting n in there. Now this next one, when we go to multiply it, power raised to a power or multiplying like bases, we have to have like bases now. And I can see that this is a base of 81 and this is a base of 3. So I can probably decrease this base down to the value of 3. So in doing so, well, I know, just think about it, 81 is 3 times, or 3 to the 4th power would give me 81, right? 3 times 3 times 3 times 3 is going to be 9 times 9, which is going to give me 81. So I can rewrite that as 81 is going to be 3 raised to the 4th power, we're still raised to the 5th power right here, is going to be equal to 3 raised to the x power. So that is going to be 3. And again, looking at my exponent rule, oops, didn't mean to do that. Looking at my exponent rule, remember we're multiplying. Powers raised to a power, we multiply. So power raised to a power, that would be 20. So that would be 3 to the 20th power equals 3 to the x. Well, again, if we have like bases, then my powers are going to be equal to each other, my exponents. So that means x is going to be equal to 20. So 3 to the 20th power is equivalent to 81 to the 5th power. Okay, and we're going to have to do the same thing over here. In this last example, I don't have like bases, so I want to work to get a like base, and 2 would be a good like base because 16, that's a factorable by 2. So 16 would be the same thing as 2 to the 4th power, 16, still raised to the 3rd power, and that's going to equal to the x power. So again, power raised to a power here, that's going to be 2 to the 12th equals 2 to the x, and then so therefore, if I have like bases again, my exponents are going to be equal. I know that x is going to equal 12. So there you go. There's doing powers of a power. And powers of a product. Okay, so this power of a product is very, very similar to the power of a power. But I'm going to have to remember that this exponent goes to everything inside the parentheses. So that's why AB raised to the m power is going to be A raised to the m power times B raised to the m power. So again, these are just our normal exponent rules. So 4, in this example, 2 is going to be raised to the 4th power. X is going to be raised to the 4th power. And y to the 3rd is going to be raised to the 4th power. So if I go ahead and rewrite that, then it's going to be 2 to the 4th power times x to the 4th power times y to the 3rd raised to the 4th power, which 2 to the 4th power is going to give me 16, x to the 4th, and then y is going to be raised to the, right here, is going to be a power raised to a power, so that is going to be y to the 12th. Okay, there you go, using my exponent rules. Let's see here, we've got some more stuff going on, and it does tell us to use, when we're having multiple operations, we always want to go from the inside out, but looking at it, I don't think there's anything we can do inside this radical, or inside the parentheses. So I'm just going to go ahead and say, okay, well, that is going to be, right, each one of them are going to be raised to the exponent of 3, so that's going to be 8 to the 6th raised to the 3rd power times y to the 8th raised to the 3rd power over x squared, y squared, and that is going to equal x to the 18th, y to the 24th over x squared, y squared. And continuing on with our exponent rules, I'm going to have x to the 18th minus 2 times y to the 24th minus 2, which is going to be x to the 16th, y to the 22nd. And there you have it. We did a lot of the exponent rules there in that example, but it will work out for us in the end. The power of a quotient, again, much like the power of a product, we are going to take, and we have a over b to the m power, so that's going to be the same thing as a to the m power over b to the m power. So, looking at my first example here, I'm going to have everything to the second power. So I'm going to have ac to the fourth to the second power over 3b to the third raised to the second power. And using my rules again, that is going to be a to the second, c to the fourth raised to the second. Because again, the second power goes to both of those. The second power goes to both of those. And that is going to, the denominator is going to be 3 raised to the second power, b to the third raised to the second power. So now I can go ahead and do some more simplifying. And that is going to be a to the second, c to the eighth, right? Because that is a power raised to a power, so it's going to be multiplication. And then I'm going to have all of that over 9, and then b raised to the sixth power. Again, a power raised to the power is multiplication. Does not look like there's anything more for me to simplify in there, so that is my answer. And continuing on, goodness gracious, what could be my x and my y values be here over here in this example? So I have a to the third, b to the fourth over a to the second, b. And I can just do some simple simplification here. So that my a's and my b's, so I'm going to have a to the third minus 2 times b to the fourth minus 1, right? And then that is going to give me a to the first, b to the third. So according to that, y is going to be equal to 3, x is going to be equal to 1. So x equals 1, y equals 3. So there you have it, as we utilize all the product quotient. The laws of exponents. We're applying those properties of whole number exponents to generate equivalent expressions. And of course, we did look at the base, the exponent, how it expands, so we could tie that in together to how we utilize these rules to help speed up our long addition and subtraction. And just remember, when you're simplifying expressions with multiple laws of exponents, make sure to work from your inside out. So there we go. And we're going to work with this, and hopefully it all just starts to click, since this will be the third year that you have been working on exponents.